Clara. I'm currently a data scientist at AT&T, where I'm leading the projects in machine learning, AI, and Gen AI. Currently, my office is located in Alpharetta, Georgia, so I'm local. Before joining AT&T, I studied at GSU, where I earned my PhD degree in mathematics and statistics, with concentration in like graph theory and combinatorics. So now, currently in AT&T, I'm focused on leveraging the advanced technologies to optimize the customer care and the field technician operations. So today, for example, this one is a real project we did for the last 2 years. This one has significantly improved the customer care interaction, and also if you notice AT&T, if you like buy AT&T stocks last year in the second quarter earning, this project is highlighted in the earning calls, and also we earned the AT&T Service Optimum Award. So without further ado, I want to share some learnings, insights with all of you today. So I will quickly go through some my understanding of the search and the retrieval-augmented generation, and also how we build the retrieval-augmented generation into production and how we evaluate. I think just now Ethan already gave a very good introduction. If you are here for the last talk, he mentioned a lot about the semantic search and also vector store. That's exactly what he experienced. And also I will mention some development challenges and also the future work we will do. So I'll start with very simple introduction. Like each day, I think we start with questions, searches. Like for example, this morning we ask, what's the weather like? And then you will search your phone or website for the answer. And then another question will be asked, any email I missed today? So you can check your mailbox for the answers. And then when I drove to office, sometimes I will open my phone listening to a podcast. Then someday, somehow it doesn't work. Then you will wonder, what kind of unlimited plan I can have? Then you may call your provider, or you search online, right? So if you call your provider, then sometimes I can tell you the agents also need to search for the answers, because there's a lot of offers, plans, they keep changing every day or every minute. So even though you have very good memory, it's good to double check. So that's the situation of our customer care agents. They also need to search. They search like thousands of articles for an answer. We can't eyebrows the sources for answers until your query are so complex. They are combine several answers from a lot of multiple different articles, or your article, like your knowledge base, get expensive. So there's a lot of different and dynamic knowledge documents you need to search for. And then another one is the domain specific. There's a lot of articles, they are not publicly available. So you've been searched, but you cannot find the answer. So this also same thing for our agent, is domain specific. And also, as I mentioned, the contents can update very frequently. Sometimes they require the near real-time refresh. So in this case, all in all, that's how I say the traditional keyword search may not work. So this move on to the search patterns. So traditionally, we say, hey, we have the question, we type the keyword, then we have a list of sources or documents, then we can read, and find the answer. I think since the GPT release, right, we get a new pattern like, hey, I just type my prompt or query questions, and then the large language model will give me the response. But there's a limit. We all know that the LLM is trained based on the some cutoff of the knowledge. So it may not be updated for the answers. So now there's a new habit. Like we not only want to have the response generalized by the LLM, we also want to see the sources so that we can check the reference, see if everything is good, and check if there's any hallucination. Hallucination, I think, is a very buzzword now, so we heard everywhere if we use the LLM. So actually, this is the some AI assistant we built for the AT&T agents. So they already have used it for several years now, I think for the last 2 years. And there's a lot of greater feedback, like, the experience getting faster. I think I can serve my customers with greater efficiency. And this is some real feedback, like it's a game changer. I think in the beginning when we released the UI application to them, they said, I tried to trick it, but I cannot. So they tried a lot of questions. Later I will mention some real scenario questions they asked. And also some of them mentioned, I spent 15 minutes yesterday to searching for some plain code in the old legacy search, but today I just spent 50 seconds with the Gen AI assistant. So then the technology behind the scenes is retrieval-augmented generation, RAG. I think our journey started very early before RAG even becomes the buzzword now today. I think, as I mentioned, end of 2022, I think that's the time when ChatGPT released to the public, and then everybody heard about Gen AI, I want to try it. And then in early 2023, we already built our first RAG pipeline. And then the same year, we pushed the pipeline into production. And then last year, we already have some pilot users. The user gave really a good feedback because that's really changed the way they serve the customers. And our results as a pipeline, as I mentioned just now, also get highlighted in the AT&T earning calls in the second quarter. And then later we build more features because once they use it, they will have more ideas. Oh, how about this? How about that? So we add a lot of features on according to their feedback. And then we have the nationwide launch. So this year, we try to enhancement because there's a lot of new technology pop up, like agentic world, right? So it's another buzzword now. So we try to do more enhancement to this pipeline. So back to RAG. I think some of you may be already familiar with the RAG. So I just want to quickly mention. So for RAG, before RAG, right, retrieval, so you need to have a retriever, and then you have a lot of documents, and then combine with documents with another guide into the prompt. You can give everything to the LLM. LLM can generate the answer. I think the way we try to have this one is that, as I said, LLM has the cutoff of the knowledge. We want to have the retriever to retrieve some chunks as the background context so that LLM won't hallucinate or make up some answers. But before that, we know that to do the retrieval, as I think Ethan just mentioned, we need to do the semantic search so that we need to have vector store. You need to vectorize everything to a vector store. So for us, there's maybe more components you can add, but basically I think the idea for RAG is very similar. So for us, we have some AT&T version because security is very, very important. And also the articles are domain specific. We cannot release it to public. So then we have some platform called AT&T to secure everything we do. I want to bring more details like for each step. For example, the knowledge base side. You have a lot of documents. So your documents can be different format, maybe structured, like the tabular data or CSV, Excel, or maybe it's unstructured, right? So you have PDF images, or even like at AT&T, we have a lot of websites. It's an HTML file. So you need to do some pre-processing. That's necessary. And then for the embedding model part, also there's a lot of choices, right? So before you move to the vector store, so there's also a lot of embedding models you can choose. So recently there's a lot, I think the famous one would be the BERT-based. There's a lot of different variations. But before that, embedding model have the limit, right? So not all the, like you can not get the whole sentence or whole article embedded because like for BERT, usually it's 12 token limits. So in this case, that's why we won't have the chunk. So there's a lot of different trunking strategies. Like long chain is also very familiar, very famous. Like there's a lot of splitters there. You can choose like different splitters according to your format. And also you can specify your chunk size and also how you overlap the chunk. And after that, then for the searching algorithm, we mentioned that semantic search. Semantic search is like you have the vectors. You can define your metric like cosine similarity. So if the cosine similarity close to 1, then they are very highly relevant. But I think there's another way, like the keyword search, right? Usually we have keywords, so that's the very sparse, but it's also, for some cases, it was very useful. So you can combine them together. I think some vector store or the vendors, we call them hybrid search. Then move on, you can also add in you have a lot of candidates after retrieval, but not all of them are relevant. And also before you move on to LLM also have the token limit. You cannot push everything there. So then it's necessary, if you want, you can also add in the re-ranking strategy. For re-ranking strategy, there's also a lot of different ways, right? You can choose a model. Like there's a lot of cross-encoder models. Or you can just define your own rule. So according to the business use. Like, for example, if I mention token, maybe you say, oh, for token, it's like RC token for security. And other token maybe, oh, the token to buy something, some credit. So depending on your business or your use case, you can also define your own rule to re-rank everything. Once you have everything, now we can move on to the LLM. For the LLM, then there's also a lot of work you can do, right? So like, I think there's different large language models. I don't want to mention just specific one, but but the parameters are kind of similar. For example, you can say for the temperature, right? You can tune the temperature. I don't want to have my LLM too creative because I don't want to, for this one, the answer should be there. Even for some verbiage, maybe we need to control that. Hey, don't go too random. And also there's the top K or top P something, right? So for the next token, I don't want to generate from the random. I don't want to say, hey, the top relevant something in the sample. Then, okay, you get the top something. And then definitely prompt engineering. So different prompt may give you different output. And also different LLM also work with different prompt. I think for prompt, there's a lot of rules. If you search online, you can get a lot of feedbacks or experience. I think from our side is that specify the role play. That's helpful. Like, for example, you are very helpful care agent. You are here to assisting customers. And then specify the role. And also specify the task. I think there's one common example is that don't just ask, hey, tell me something about the climate change. Be specific, like show me the recent climate change and also show the impact to the global, blah, blah, blah. So anyway, and also you can show some examples. Give them examples like, okay, you are a firefighter, you are agent, then describe something. So there's a lot of things to do. I think, yeah, in my mind, I cannot remember all of them, just list some of them. So yeah, so there's definitely work to do. Like just, hey, I got this one, I paid for some they're also open source, right? I have this one, they show this very powerful. Doesn't mean they just work for your use case. So you need to, according to use case, according to your feedback, you need to still do some prompt engineering. And after that, then we combine everything. Sometimes we also do some post-processing. For example, when we do the hallucination control, we say, hey, if you do not find any answer, do not reply. Maybe say something, hey, I don't know the answer. Can you try to rephrase? Give them some guidance. So, in this case, I don't want to give the citations because I didn't get the answer. So this is some post-processing we did. And then now move on to the evaluation. So I think just now some people will ask accuracy, right? So accuracy is definitely the first important metric we need to use. So since for RAG, we have the retrieval part, we have the generation part. And then for retrieval metrics, there's also a lot. I think I listed some of them, like blue, ROG, and the ROG recall at K. And then for generative part, you can also use the blue ROG, but since it's generative answer, there's some change. For ROG and blue, they are using the overlap, right? The overlap of the generative answer, overlap of the truth, and then divide by which one we want to say. If we say recall, then divide by the truth. If we say precision, then divide by the retrieved chunk. But generative answer, sometimes they rephrase. Semantically, they are the same meaning, but the wording is different. In this case, the ROG score can be very slow. So in this case, we can also use another method called LLM as a judge. I think this one is also another buzzword now. 2 years ago when I started, I don't think I heard a lot, but recently if you go to some monitoring system, they always mention LLM as a judge. So I will give some example like what I did last year, how the ROG and recall can work well for the chunk level, right? Retrieve chunk level. So for this one, I forgot to mention, human evaluation definitely sometimes we need it because no matter how good LLM, sometimes for some level, I think maybe in the future it can work, but so far we still need the human evaluation. So for this one, for example, the human evaluation, we have 200 QA sets. I think when you do the evaluation, you need to have the truth set. That's our truth set. Then by the human grade, we have different levels, like the answer is correct. Then if you check the ROG and recall score, you can see the score is very high, nearly 1. And then we have another level like it's incorrect. Then you can see the score is very low. But sometimes correct, but incomplete. You can see the overlap is not 100%. The score is a little bit lower. Just want to show you as an example. ROG-N score is one of them that I tried. I feel it's good for some scenarios. And also then we will move on to production. Definitely, besides the accuracy, latency is very important, and also scalability, and definitely cost. Sometimes you have a very fancy model. Oh, I want to try this one. This is really good. In the Hugging Face, the benchmark is #1, but we cannot use it sometimes, right? So open source maybe, but that's a security issue. And then the other one, the private model, is very expensive. So there's a trade-off. We cannot choose the best sometimes. Then we have to work with what we can do, and then to make the best use of the available one to us. So for the more than just RAG, as I mentioned, there's some scenario like it's already beyond RAG. For example, user will ask, read my mind question, like Apple. You need to understand I'm asking fruit or the company. And also they said, oh, I don't have time to type a full sentence because I'm serving customers. You cannot say, hey, give me a very high quality questions. They just type keyword. You need to figure out what I'm asking for, right? And then they also expect the verbiages, as I mentioned, so they cannot rephrase. Or they can do math for me. So if one line is how many dollars, then tell me 5 lines. So they want LLM to do RAG to do the math for them. And then they also want to do summary for everything, right? As I said, we have chunking. We cannot provide everything to them, but sometimes they expect, okay, the whole graph or whole several documents do the summary for everything, but that's already not RAG. They can use the summarization actually. Or remember all I searched. So this one actually we have something to do like multi-turn. We turn another feature, use the conversational context search. So you can push the history, and then the history, the chunk, and the prompt, you can move on to the LLM. But there's also limit, token limit. You cannot say I can get everything, right? For the history, maybe I can only last 10 rounds of history queries, but not all of them. Okay, so for other challenges, right, besides this, we also need to say, hey, we have so many users, then how can we manage all of them while still ensuring the optimized response time? So that's another trade-off. Sometimes the model is good, but it's too slow, so we cannot use them. So there's another trade-off. And also the effective access control. We have retail agents, we have customer care agents, we have mobility agents. They cannot read each other's documents. Then we need to have access control. For this one, you can use the RBAC. I think if you search online, there's also a lot of other features, right? You can add filters when you do the payload to search questions. Then recently, we also say we have agents in US, agents in Mexico, agents everywhere. They speak different languages. They want to say, hey, how about do the multilingual search, or even cross-lingual search, sometimes because most of the documents are English. So if I'm a Spanish speaker, can you search English but return in Spanish? So that's another challenges the user expecting. Okay, so if we want to learn more, from our chief data office, from AT&T, early last month, there's NVIDIA GTC. Our leadership did some panelists there. So one of them is delivering the real business outcomes with AI in telecom. The other one is AI agents and digital humans shaping the future of interaction in telecom. So they mentioned a lot. So as I mentioned that Ask AT&T is our platform, but in the platform we have a lot. Like the one I just mentioned, RAG, is Ask Doc. And we also have Ask Data. Ask Data is to naturally from test to SQL. Also, there's a benchmark called BERT. I think AT&T sometimes ranked #1 there. I think our leadership is really proud of that. And we also have the Ask Image, that's for the vision, and Ask Workflow, that's for the agent work. So future, as I mentioned, there's still a lot we can do, a lot add on. And also graph theory is, graph RAG is another topic we kindly tried. So because in production, if you want to move or release something, it's really hard. We need to go around a lot of CI/CD circles. Then definitely agentic work, agentic RAG, right? So everything not today. So I don't want to limit it to just RAG. We want to use tools. We want to use so many things. So our users, actually, their expectations get higher, higher, higher. 2 years ago, they say RAG. They say, oh, everything's good. But now, after 2 years, I would get used to it. Give me more. be faster, be more accurate, and also read my mind, right? So if I want to see the same thing, okay, you need to know what I'm talking about. So don't just give me citation and response. Tell me more, work on more. So thank you, that's all. If you want to connect, yeah, this is my linking. Thanks, everyone.